Hey students, Mr. Wagner here. We are virtual today. I wasn't feeling so great today, so I took a sick day at school, and so our class is going to be virtual, and we're going to go through some notes together virtually. And I know it's not ideal, but this is hopefully going to work for us. And I suppose let's get started. Also, make sure you take a look at the email. I'm going to remind you of a few things like your biblical application paper, as well as some links to play your Kahoot and things like that, and some assigned watching. Okay, so in our last section, we talked about solutions, we talked about colloids, we talked about suspension, solubility, solubility curves, solutes, solvents, things like that. Well, lumped into all this when it comes to solutions is we need to talk about acids and bases. So first off, let's talk about some properties of acids. Acids overall, they're pretty sour. Not that you should try all acids. So things like grapefruit, oranges, limes, those are very acidic. They've got kind of a tart, sour taste. And the other thing that you should know about acids is that they are corrosive to metals. They start to eat away at metals, and they react with metals. It just so happens your teeth are made up of calcium. Calcium is technically on the periodic chart considered a metal. So when it comes to things like carbonic acid, which is in soda, it is going to react with your teeth over time to eat away at your teeth. So if you're eating highly acidic foods, like pasta sauces, lemon juice, I don't know who drinks lemon juice, orange juice, but usually the most problematic one is pop. Okay, so here's some more things that you should consider when it comes to, or some things that are acidic. Lemon juice, stomach acid, carbonated beverages, tomatoes, batteries, and vinegar. All these things are highly acidic, and maybe if you've worked with some of these things before, like if you've eaten a lot of pizza or pasta sauce, you can get some acid reflux. Also, we used to have a cat, and our cat would eat our Christmas tree and then throw up on the floor. And the acid from the stomach of the cat would kind of like dissolve some of the finish on our hardwood floor, and I wasn't too happy about that. Okay, so here's some more things you need to know about acids. These are different kinds of acids. Take a look at the name and then the chemical formula. Hydrochloric acid, that's the one in our stomach. Nitric acid, HNO3. Sulfuric acid, H2SO4. Carbonic acid, this is what's in pop, H2CO3. Acetic acid. Acetic acid is, I believe, another name for vitamin C. And phosphoric acid. My question to you is, what do all these acids have in common? So if you're looking at these acids here, look at their chemical formula. What do they have in common? They all start with an H, right? That H is a hydrogen ion. Now, we talked about ions in the past. An ion is essentially a charged atom. It's an atom that's either got an extra electron, which makes it negative, or it's missing an electron, which makes it positive. So in this case, it's the hydrogen ion, the H+, which means it's missing an electron. And if it's missing an electron, it's H+ ion, hydrogen plus. I am going to ask you in the future to identify an acid or a base based on its chemical formula. Okay, so chemical formula for acids, they always start with an H. Okay, so, by the way, it says, remember, an ion is an atom with a positive or negative charge. In this case, the hydrogen atom has lost an electron. That's what makes it H+. All right, let's continue. Let's go on to bases. Bases, of course, the opposites of acids. Bases, they taste bitter. I don't know if you've ever had soap in your mouth. It's gross. It's not sour. It's bitter. Bases are always slippery whenever they're wet. And bases are often used for cleaning. So these are some characteristics of bases. Soap is a base. Ammonia, which is in Windex, that's a base. Toilet bowl cleaner, Drano, all those things are pretty strong bases. So here are some things that are basic. Oh, I kind of gave it away, didn't I? Soap, that's a base. It's not a very strong base because if it was super strong, it would hurt your hands. Windex, which the ammonia In Windex, that's a base. Drain cleaner, very, very strong base. Be very careful with drain cleaner. Baking soda, that's a base. Not too dangerous because we eat it. And concrete mix. So all those things would be good examples of bases. Oh, and by the way, an antacid, I forgot about that one. So the antacids, it neutralizes your stomach acid, and we'll talk about neutralization in just a moment. Okay, so here's some chemical formulas for bases and some names for bases. So take a look at these chemical formulas and their names. We got sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium hydroxide, aluminum hydroxide. Hey, by the way, this stuff is in deodorant. I don't know if you've ever noticed that. So what do all these bases have in common? I'm looking particularly at their chemical formula. What do they have in common? They'll have a hydroxide ion. Now remember, the hydroxide ion, now we're talking about not just an atom that has an extra electron, but instead of just an atom, now it's a molecule that has an extra electron. So it's oxygen and hydrogen chemically bonded together, and it's got an extra electron, which makes it negative, right? There's a video that goes along with this, and I put a little caution there because there's a swear in the video, which I wish there wasn't. That bothers me. But it's a TED Ed video, and I think it really summarizes how acids and bases work really well. And here's just a reminder. An ion is an atom or a molecule. In this case, it's a molecule with a positive or negative charge. In this case, the atom has lost an electron. Let's change that. It's actually gained an electron. I need to fix that. I'm sorry. So it should be gained an electron. Don't say lost an electron. It is gained an electron down here. So in the description of this video, you should find a link for the TED Ed video on acids and bases. If you wouldn't mind pausing for about 4 or 5 minutes to watch that video, I think it will help your understanding. Okay, moving on to the next slide. The next slide, let's talk about the pH scale. We can't talk about acids and bases without understanding the pH scale. pH stands for the potential of hydrogen. That's why the small letter P at the beginning, it's lowercase, and then the H is capital because it's representing hydrogen. So it's the potential of hydrogen. It's a measurement of the concentration of hydrogen ions. Now remember, acids have hydrogen ions. If there's a whole lot of hydrogen ions, we're going to call it a strong acid, right? So the pH scale ranges from 0 to 14. You probably know this. 0 to 7 are acids and 7 to 14 are bases. Here's a picture of the pH scale. You can see way down here, very acidic. This is, what is that? I can't read that. It's an acid. I'm pretty sure it's the stomach acid, hydrochloric acid, which is a pretty strong acid. And then over here, this is sodium hydroxide. Sodium hydroxide is a very strong base. Take a look at the middle here. 7. That's neutral. It means it's not an acid. It's not a base. It's neutral. It's right in between. One thing to keep in mind is when we talk about the pH scale is logarithmic. And what that means is when we go start at 7 and go to either side, it increases by a factor of 10. So when we go from 7 to 8, an 8 is 10 times more basic than a 7. And a 9 is 10 times more basic than an 8. And a 10 is 10 times more basic than a 9, but 100 times more basic than an 8. So this increases exponentially. It's a logarithmic scale when we're moving up and down the pH scale. Okay, so indicators. One of the things that I wanted to show you as a demonstration in class, I'll have to find a video for it. If I do, I'll link it down below. But I wanted to show you a demonstration when it comes to indicators. An indicator is any substance that can identify the presence of an acid or a base. It lets you know if the solution is an acid or a base. That's what an indicator does. It indicates that for you. One popular indicator is litmus paper. Litmus paper is an indicator. Another indicator is phenolphthalein, which is kind of a weird word to pronounce, but phthalate is an indicator. And once in the presence of an acid, it's clear. But in the presence of a base, it's that beautiful pink-looking color. God has given us all sorts of natural indicators, which is kind of neat. You could use blueberry juice. It could be cherry juice. But usually some dark vegetables, dark fruits, when you grind those up and put them in a solution, they make a good indicator. In this case, cabbage juice is a great indicator. If you wanted to do this even in your elementary classroom, you could get some cabbage juice and then find whether some pretty simple things are acids or bases, right? So you could try this with soapy water. You could try this with milk. You could try it with a few things like that. And here's the pH scale using cabbage juice. So it's this bright pink when it's an acid, turns green when it's a base. Okay, so what happens when you mix in an acid and a base together? When you put an acid and a base together, that's called neutralization, right? That's a key word, is neutralization. Here is a simple neutralization reaction, right? This is a very important neutralization reaction. Here on the left, we've got hydrochloric acid, right? It starts with an H, HCl. And then we've got a strong base, sodium hydroxide. How do we know it's a base? Ends in the hydroxide. When you mix those two things together, take a look. The H plus, which is positive, reacts with the OH, which is negative, and together they form HOH. So the H from the acid comes off, the OH from the base comes off, they link up together and they make HOH. Another way of saying HOH is H2O. We just rearranged it and said, okay, now it's H2O, right? And then what do we have left over? The Na, the sodium, and the chlorine. Sodium and chlorine, they come together and make salt. In my opinion, this is one of those examples of a reaction that shows order in our universe. There's no way that this is an accident. It makes sense that we have an acid and a base, and together it's going to make water and a salt. Again, I think this is just one more piece of evidence that our universe is not an accident. Our universe is created to look this way. There is a Tim and Moby video that I found for you guys that kind of goes over acids and bases that I want you guys to watch. But that's pretty much it for our lesson. So when we come back together on Thursday, we'll be doing some demonstrations, some more review, and then starting our last topic for the year. But thank you for listening and participating. Please watch those videos down below. Don't forget about the assigned watching. And I also do have an assignment for you on Canvas. Check the email to find out more information about that. But I hope you have a great and wonderful day.